Hello everyone. Today is 3rd June 2021 and my name is Rajat. I am from Electronics and Communication 6th semester, and today I'm going to be speaking on the topic transparent electronics. So transparent electronics are also called as invisible electronics. It employs wide band gap between semiconductors for realization of invisible circuit and optoelectronic devices. The first goal of this technology must be to discover, understand, and implement transparent high performance electronic material. And the second goal is their implementation and evaluation in the transistor and circuit structures. And the third goal relates to achieving application specific properties, since transistor performance and material property requirements vary depending on the final product device specifications. So the material used for transparent electronics, there are mainly two materials that we use for transparent electronics. The first one is transparent conducting oxides, and the second is thin film transistors. So the transparent conducting oxides, in short form known as TCOs, are electrical conducting material with comparably low absorption of light, and they are usually prepared with a thin film of technologies that are used in optoelectrical interfaces and circuitry. So they are basically thin and and absorb low light. So high optical transparency and high electrical conductivity are the traits. And the most common transparent conducting oxides that we use are indium oxide, tin oxide, and zinc oxide. And you can see it in the diagram. This is a TCO, which has a optical transparency, high electrical conductivity. Thin film transistors, also known as TFTs. A thin film transistor is a special kind of field effect transistor made by depositing thin films of active semiconductor layer as well as the dielectric layer and metallic contacts over supporting but not conducting substrate. This is the diagram of a thin film transistor, as you can see on the right side on the screen. Uh, Channel is performed from highly insulating wide band gap transparent semiconductor, also known as ZNO, and two possible configuration are bottom gate and top gate. As you can see, these are the bottom gate TFT and the top gate TFT. One has the gate on the top and other has the gate on the bottom side of the transistor. So transparent electronic devices are basically of two types, transparent passive and transparent active devices. So the devices which are passive devices, transparent thin film resistors, transparent thin film capacitors, transparent thin film inductors. So basically the materials that the passive devices, the passive materials we use in the construction of a transparent device are basically transparent. So uh, transparent thin film resistors are resistive material, and ITO, indium tin oxide. As you can see, conductivity of a transparent conducting oxide depends upon the number of oxygen vacancies in metal atoms occupying interstitial sites. So you can see transparent thin film resistors and transparent thin film capacitors. So most are insulators. Most insulators are transparent, and contact layers is made of highly conducting TCOs. This is the diagram of a thin film capacitor. Transparent thin film inductors, hard to realize due to poor conductivity, and high inductor requires large number of turns, which in turn returns in increased parasitic resistance. So application of transparent devices are they are anti-static, used in anti-static coatings, touch display panels, solar cells, flat panel displays, heaters, optical coating. Uh, recently the companies like Samsung, LG, and Panasonic are trying to build transparent devices such as smartphone transparent televisions, which are in market, but they are progressing over time. So the conclusion of this presentation was oxides that represent a relatively new class of semiconductor materials applied to active devices such as TFTs and SWNT transistors. The combination of high field effect mobility and low processing temperature for oxide semiconductors make them attractive for high performance electronics on flexible plastic substrates. And thank you for watching.